This video describes how to check models with validation rules. Visicon provides in-depth access into BIM data and supports quick and systematic quality control of models with validation rules. Validation rules are easy to create and unlock underlying model data. Use them to visualize data or quality control your model. There are two types of validation rules: those that uniquely colorize components based on any parameter selected, and expression-driven rules that can be set up for any condition. Rules can be grouped into rule sets and saved as templates for easy reuse on similar models. Use rules to gain better insight into your BIM by colorizing different model data and make faster and better decisions. Use cases include identify, group, and colorize unique slab thicknesses, isolate and color code rebar with a certain bend diameter or length, find pipe in your project with a given diameter, color code components by their construction status, or visualize components based on any other available model property. Rules can also be configured to check against any condition, not just identifying component properties. Apply these rules to automatically identify irregularities in your model and improve quality control. Example use cases for quality control of a model include checking to make sure drainage pipes have minimum slope, that where expected beams are assigned uniform section properties, windows have been modeled with a correct height, wall dimensions are within an acceptable range, or identify slender structural elements that may require a more detailed review. So how do validation rules work? Rules work by applying a condition to any number of project parameters in your BIM. Component visibility changes are applied to the pass and fail outcomes of the condition. This simple construct supports the creation of automated data validation and visualization workflows. The simplest condition for a rule is the uniqueness of any component parameter, for example, slab thickness. You start by taking any component parameter, create a new rule, and enter the parameter name in the uniqueness field. The pass condition, which in this case means a component has the thickness parameter, is automatically configured to assign a variable color to affected components. All other visibility properties are ignored. By default, the fail condition is set to ignore all visibility settings. We will switch to Visicon and show how easy it is to create this rule. We've opened a Revit model and our objective is to colorize all of the slabs based on their unique thickness. We'll start by selecting a slab. If we open up the object properties and we scroll down, we can see that they're all the various properties. We can write rules with respect to any of these. These are general Visicon properties. The next tab includes all instance properties that were imported from Revit. The next tab are all of the family parameters. So in our case, we're going to just go to the general properties. We see the property thickness. So to reason about any variable, you simply identify the variable for the component, right-click, copy the variable. We're going to go now to our project browser, open the rules. We're going to create a new rule. We're going to call this slab thickness. This is going to be we have expression rules, which are going to be done next. Uniqueness. I right-click, paste the variable, right-click, and we can see that now this project has been colorized and each component has a unique color based on the thickness parameter. We see that in this case it applies to both walls and slabs. If we go to visibility, turn off our columns, for example, we can see that all of the walls, and let's actually turn off the slabs as well, all of the walls as well as the slabs have now been uniquely colorized. So it makes it very easy to be able to communicate what you have in your BIM model to other project participants. Expression-driven rules give you more options and can be configured to check against any constraint expression. For example, the slope of a slab. We will switch back to Visicon and create such a rule. We're back in the Revit model, and this time our objective is to create a rule to identify all sloped slabs. So we're going to start again by selecting one of the slabs. going to the object properties, and in this case, open up the project browser, create a rule. So this is going to be called sloped slabs. We're not going to use uniqueness. This time we're going to do expression. So we need two components. We need to capture and isolate slabs first. So as we've done here with this slab that's selected, if I scroll to the top, I see it has a property called type. I'm going to right click, copy variable. So first thing we're going to do is paste that variable. Say type equals structural floor. And the next thing we want to do is identify that the slope is not 0. So we're going to say and. So then we're going to look for, here we see the slope parameter. We right click, copy the variable. It's flagging us, telling us that the expression is incomplete. That's fine because we're not done yet. We're going to add this and say slope is not equal to 0. So we've now written a valid expression. What do we do with it? So we're going to scroll to the right. When it passes, we're going to say let's assign those that are sloped yellow. If it fails, which means that it's horizontal, we're going to say make the opacity, let's say 5%. So now we see that rule is applied. If I turn that off, and the program has automatically isolated and identified all of the sloped slabs and turned everything else to be 5% opacity. So this is a quick way that you can come in and do quality control and make sure you don't have any slabs in your model that shouldn't be sloped. In the next example, we'll show how expression-driven rules can also be defined to include any arithmetic calculations. For example, to check for slender beams. Again, we'll switch to Visicon. We're back in the same Revit model. This time let's go ahead and we're going to zoom in on some of these steel beams at the roof level. I'm going to select one of the beams, and again, if you remember, our objective here is to identify slender beams and use an arithmetic expression. We're going to start by grabbing the beams, similar to what we did with the slabs. We're going to come here and take the type. So we're going to go right click, copy variable. We're going to create a new rule. We're going to call it slender beams. We're not going to use uniqueness. We're going to write an expression again. We're going to come in, paste the type equals structural beam, and we want to check for slenderness. So we're going to come down and we see we have the length. So we're going to copy the length, paste the length, and divide the length by the depth of the beam. So we're going to come in, and the depth of the beam is not a generic property. It is also not at the instance level for this particular type of component. In Revit, it was defined at the family level. So here we can come in and we can see it's the HT. So we're going to copy this variable, place the variable there. So now we're saying that our complete expression is we're looking for any structural beam. Our project happens to primarily have these long steel beams, so we're checking for structural beams and where the length over the dimension HT, and let's do a measurement of, let's say, length over depth of 15. What do we do with those beams? We're going to come in here and we're going to say the color is going to be, let's say, this color, and if it fails, this time we're going to assign a gray color. So can you see how I'm going to turn this off? Can you see now how for these are all the beams that, and actually there's a beam on the back side there also, these are all the beams that meet this criteria of having a length over depth greater than 15. I can just simply come here, make this 10. Obviously, it increases the number of beams that apply. So that's an example of how you can quickly write an expression and a rule that draw on different object properties, and we're using a more complex relationship between them. Rule sets combine the results of individual rules to create more comprehensive behavior. For example, to apply standardized slab colors to a model. Let's take a look at a live example. We're back at the same model. We're going to open up the project browser, go to where the rules are listed. This is one of the projects that comes as a sample when you install Visicon. And what we can see here is some example rules. So here is colorize by thickness. This is one that we actually built together. We have one with an expression that says colorize 8-inch slabs yellow, colorize 7.5-inch slabs fuchsia, and so forth. And here we go down to the bottom. You can see a rule set. The rule set, you can then assign different rules in a particular sequence to the rule set. So you can see if I select one of these individual rules, it just has the ability to assign 8.5-inch slabs a certain color. The rule set allows me to combine all of this behavior and uniformly color code all slabs in my model a standard color. Save any created rules and rule sets as templates and apply them to future projects, saving time and maintaining consistency. Create one comprehensive template or save and apply individual rules or rule sets. In summary, Visicon is a data-centric BIM platform that exposes all model data. Rules and rule sets are one of the main features used to access component parameters and act on them to either visualize model characteristics or to identify potentially hidden problems. Expressions can be written to include any arithmetic or Boolean operator. Make faster and better BIM decisions using Visicon's data-driven rules. Thank you for watching our video. Contact sales@visicon.com or sales@adaptsoft.com to request your free intro version.